بدكم تنتبهوا عم بتشوفوا شيء شير سكرين؟
لا
دكتور في
لا.
ضد شير
طيب Okay. Are you seeing the screen now? Okay. So the only thing is that here in this formula, you need to be careful to put the dot product and not just the product. Okay. I know there are vectors now. So this quantity is x is a vector. Okay. So it's a vector. So you put dot product. Okay. So you have the product elements per elements here. إذا ما بتحطوا dot product هيصير عندكم مشكلة بيقلكم error يعني. And that's if I run this program he will plot the polynomial. إيش عين الفكر؟
لا.
No.
Okay. So okay, now he plots the polynomial. So this is basically the program. Okay. There's several ways of writing a program. This is just a possibility. Okay, what I did. I don't want that you learn by heart this program. This is not the goal of this course here. Learning by heart is not the goal. The goal is that you learn how to think and how you would find a solution by yourself. You could have done this there's several methods of doing this. You could have used a matrix, save the elements into a matrix. It's not very efficient, but it works.
أنا طبعا كثير طويلة كانت.
If the interpolation points عندنا كتير interpolation points, then it takes space setting it into a matrix. Okay. But for few points it's okay. But if you have 1,000 points, then it's not very efficient. So this is basically it. And you could have done the calculation for the polynomial inside of the first loop comment. So there is several way of programming it. So there's not one way. Okay, but the thing is that you understand what is asked, and that you find how you will do it. I don't إذا طلبت منكم program بالفحص I don't like seeing my program because أنا بقول هيدا إنه حفظ البروجرام ما هو أنا كنت شايف تلاميذ قبل ما يفوتوا على الفحص عم بيحفظوا البروجرام it's like عم بيحفظوا استصغار. This is not the goal of the course. منه الهدف واحد يحفظ بروجرامات. الهدف انه يفهم شو بده يعمل وكيف بده يوصل على السولوشن. Okay. So this is it for the program تبع الفينيت ديفرنس. إذا بدكم ببعث لكم إياه بس ما تحفظوا. Okay. This is ما تحفظوا any program. Do it. رجعوا شوفوا انتم كيف بدكم تعملوه لحالكم انه رجعوا فكروا بالمشكله. اوكي فسرت لكم اياها هلا كيف فهمتوها طبقوها. Okay. So let's solve some exercises that I gave you. Okay, we'll share another screen. Okay, so for the first problem, okay, so evaluate the interpolation polynomial corresponding to the function cosine at the following points: minus pi over 2, 0, pi over 2. Yani, basically the xi, okay, are these points, and the yi are in this case the f of xi, يعني تبع الcosine. So if we find the interpolation polynomial passing to these points, this would give me an approximation to the cosine function. Okay, an approximation to the cosine function using a polynomial. This can be helpful in some cases. In any case, you have to know that when the computer computes the cosine, he doesn't compute the cosine. He compute the cosine as a polynomial. Okay, as the Taylor expression, or using the Lagrange polynomial or other polynomials. But he computed using polynomial لأنه the cosine function. Okay, the only thing that the computer can compute and التركونية is multiplication and addition. The multiplications بيعملها using addition. A computer can only do additions. Okay, and everything that he does is derived from the addition. So okay, so the Lagrange polynomial, Newton divided differences, and then you will evaluate the polynomial at the point pi over 4, and you will compare it to its real value. Okay, so let's do that. This is easy. I'll share the screen.
دكتور إذا إجا هيك سؤال بالفحص بتفضل نكتبه ككود أو الميثود مثل ما هي؟
أنا ما طلبت الكود، بس اطلب كود. When I mean evaluate, it's not the code. Okay, evaluate it analytically, and then I can ask the code, write the program, write the code, write the algorithm. Okay, I can ask this. But if I say evaluate, it's analytical expression. Okay, it's not. Okay, so basically you have the point xi minus pi over 2, 0, pi over 2. The yi will be the cosine of these points. So okay, cosine تبع minus pi over 2 is 0. 0, so it has 0. So the only thing that I need to calculate here is, so إذا أخذنا Lagrange polynomial, okay, so the polynomial is the sum of yi li. Okay, so this is I equals 1, 2, 3. Okay, so because these yi are 0 here, so this is, in this case, I just need to calculate L2. Okay, the Lagrange polynomial at the point 2, which is equal to the difference product x minus xj over xi minus xj. Okay, a different than I, so it's pi x minus xj divided by xi minus xj. Here xi is 2, I is 2, so it is x minus x1 multiplied by x minus x3. Okay, here it's I different than j. Okay, j different than I. Okay. It's this the sums goes from j1 till n. Yeah. So divided by x2 minus x1 by x2 minus
x2 minus x3.
Okay. So here it will give x minus x1 is over pi over 2, and here it's x minus pi over 2. So it's divided by x2 minus x1. So x2 minus x1 is
Pi
pi
over 2.
at x2 minus x3 is minus pi over 2.
Minus pi over 2.
It's minus 4 over pi square multiply by x square minus pi square over 4.
Over 4.
Okay. The polynomial would be, okay, here y2 is 1, so it is L2.
L2.
Okay, it's simply that. X square minus pi square over 4. For the Newton divided differences, okay, you need, so it's y1, y2, y3, y of x1, x2, y of x2, x3, y of x1, x2, x3. So in this case, you need to calculate y of x1, x2. This is y1 minus y2 minus y1, sorry, divided by x2 minus x1. So y2
1 minus 0.
minus 0 divided by x2 minus
0 plus pi over 2.
x2. So it's 2 over pi.
2 over pi.
Okay, y of x2, x3 is y3 minus y2 divided by x3 minus x2.
0 minus 1.
0 minus 1 divided by
Pi over 2.
x3 minus x2 is
Pi over 2 minus 0.
This is minus 2 over pi.
Mm-hmm.
And y of x1, x2, x3 is y of x2, x3 minus y of x1, x2 divided by x3.
x3 minus x1.
Okay, so this is minus 2 over pi minus
2 over pi.
divided by x3 minus x1
Pi over 2 plus pi over 2.
يعني pi. So
pi.
minus 4 over pi squared.
Mm-hmm.
Okay, so at the end, the polynomial is y1, يعني 0. Okay, so it's 0. إذا بدكم نرجع نكتبهم يعني y1 plus y of x1, x2, x minus x1 plus y of x1, x2, x3, x minus x1, x minus x2.
X minus x2.
Okay, so y1 is 0 normally, plus y of x1, x2, so it's 2
over pi.
Multiplied by x minus pi over 2 plus
pi over 2
and a minus 4 over pi square. Okay, x minus x1
x plus pi over 2
x plus pi over 2.
وهونيك كمان قبل
x minus x2 is x2 is
x2 is 0 يعني
0.
x بس هونيك هي x plus pi over 2 تاني term
صح؟
يعني هي x minus pi over 2
Yes, you're right. Yeah. So we should get the same polynomial that we got for so إذا ناخد هون x plus pi over 2 نحطه factor. Okay. Then we get here 2 over pi minus 4 over pi square by x. Okay. يعني إذا حطينا هون 4 over pi square, okay, just like to see if it's the same polynomial, or minus 4 over pi square, okay, then it's x plus pi over 2 multiplied by, so here,
x minus pi over 2
minus pi over 2, so it's the same polynomial. Okay, it should be the same polynomial, so it's just one. Okay, if you evaluate this polynomial at the point pi over 4, okay, this should give you an approximation of cosine pi over 4, okay, using polynomials and 3 points. So pi over 4 plus pi over 2 multiplied by x pi over 4 minus pi over 2. So it's minus 4 over pi squared. And here you have, so this is 3 pi over 4. And this would be pi over 4. And you have 3 pi square over 16.
بس دكتور لا استعملنا هيدي الميثود مش اللاجرانج.
استعملنا الاثنين.
هي ذاتها.
No, هي ذاتها.
Should
same polynomial.
Repeat it 1,000 times. You have just one polynomial. You can use any method you want. But I asked in the problem to first use the Lagrange, then use the Newton. Okay, but no matter what the method you use, you should get the same polynomial at the end, because there is one polynomial interpolation polynomial of order n minus 1 passing through n points. So here you have 3 points. Then you have the polynomial 1 second order polynomial. But okay, شو ما كانت المethod that you use, even the barycentric, it should give you the same result. Okay. So here normally, so it's minus
minus 4 over pi square.
4 over pi square. Okay, so this is minus 12 over 16. لا بس انه في شيء غلط.
في شيء غلط. minus 3 over 4. It's not close.
لا هي it's
بلا radical 2 over 2.
هي بس الماينس
بلا negative.
في شيء غلط بالماينس here. It's not should not be minus.
وطلعت معنا نفس
لا it should be بس أتأكد شو عملنا غلط. شيء غلط. Just the minus إنه should not be. لأن هون في minus. Sorry. Pi over 4 minus pi is minus pi. Okay, so minus.
صح صح.
Okay, it's plus. Okay.
Okay.
So this is 0.75, while the real value للcosine pi over 4 is
0.7.
2 over 2. Okay. So this would give me 0.707.
7.
Okay. So this is P of pi over 4 is 0.75, and the real value for the cosine is 0.707, over 2 here. Okay. So now you can see that you get a very close value, like even with just 3 points of interpolation of the interpolation polynomial. يعني, which is very good. Yeah. And you can calculate the absolute error. Okay. The absolute error will be 0.75 minus 0. Divided by 0.75.
.73%.
Yeah, which is very good, because
low
here just like 3 points. We will use 10 points minimum or something like this, and then you will get, okay, yeah, it's 5%, so 5.7%. Okay, so this is for this exercise. It's just to show you that the Lagrange interpolation polynomial can be used to find an approximation of a function in a certain range when you don't know the expression for a function. For, let's say that, okay, you have calculated some points, okay, or you have some experimental values, okay, and you want to find the function. So this would give you an approximation for the function or an analytical expression. The interpolation polynomial is used in other numerical method, more advanced numerical methods, okay, like that you will see in next years, like the finite element method and things like that are methods used to solve differential equations, and also in an application of the interpolation polynomials in the integration. Okay, so this is for the problem 1. The problem 2. The problem 2, I will let you do it by yourself, just like an exercise, so you can. There's no difficulty here. Just like you have to apply the formula, and you can verify with the programs, with one of the programs, okay, like that you get the right result, okay. For the problem 3, let's just like share the screen. So final approximation for the first derivative at the point xi using the interpolation polynomial passing through the point xi minus 1 f of xi minus 1 xi f of xi. What I mean by that is that like suppose that you have a function, okay, f of x, okay, and then you have a point here xi, okay. So if you use the interpolation polynomial, between the point xi minus 1 and xi, or xi and xi plus 1 is the same thing, is the line, because okay, but if you take several points, then you get a polynomial of order 2, 3. If you take 3 points, you get the polynomial of order 2, etc. And using this, you can find an approximation for the derivative. So if you use a polynomial of order 1, a line, then you would find an approximation for the first order derivative. Okay, the approximation that we know, that the approximation for the derivative is the slope of the line passing through. Okay, so just like, so for 2 points, p of x is yi minus 1 li minus 1.
مش مبين السكرين.
مش مبينة؟ طيب اوكي.
لا. اوكي.
Plus yi li إذا عم نحكي عن points passing polynomial passing through these 2 points. Okay, so this is yi minus 1 x minus xi divided by here xi minus 1 xi
minus xi
plus yi li in this case is x minus xi minus 1
minus 1
divided by
xi
minus xi minus 1. Okay, so this is minus okay. So like I said, for 2 points, xi and xi minus 1, for example, I should get the equation of the line passing through these 2 points. Okay. So what I will do now is that I will factor everything that is in function of x. Okay, and I will express the equation of the line. Okay, so like I said, this is minus xi minus xi minus 1. So this is the same term as minus 1. إذا أخذت كل شيء in front of x, then I get over xi minus xi minus 1. Okay, and here because I have a minus, so I have yi minus, okay, yi minus 1. وهون كل شيء is so it's كمان over xi minus xi minus 1. Okay, so here I will get I have a minus, so it's a plus. Okay, no, I'm a minus كمان. So it's xi yi minus 1. Okay, plus minus minus xi minus 1 yi. So this is the a1x plus a0. Okay. So it's normal. We got the line because we have 2 points. If we consider 3 points, we will have a polynomial of order 2. The polynomial is a1x plus a0. So an approximation for the derivative at the point xi would be the derivative of the polynomial. So the derivative of the polynomial, okay, is a1. Or the line is a1. So this would give me the approximation for the derivative. So f prime at the point xi is, I will put say, because it's an approximation, okay, is p of p prime xi, which is constant in this case, and it's equal to yi minus yi minus 1 divided by xi minus xi minus 1. This is for here, just if I consider 2 points, let's consider let's now consider 3 points.
3 points.
So if I consider 3 points, I will have an approximation. So I will get a polynomial of order 2. Okay, so I will get a 2x squared plus a1x plus a0. So the second derivative, an approximation for the second derivative at the point xi. Then I constructed this polynomial. I will construct this polynomial around the point xi. يعني إذا عندي function هي هون f of x, okay. إذا هيدا البوينت xi باخد واحد هون xi plus 1 and
xi minus 1.
Okay. If these 3 points are حد بعض إنه any function f, okay, behaves like a polynomial. And basically, okay, you retain the orders, the first order of the Taylor expansion. So you can approximate any function by a polynomial. So the approximation of the derivative of the polynomial be an approximation to the derivative of the function. Okay, so is approximately equal to here So if
2a2x.
No, it's equal. So so when you derive 2 times
2 times.
the polynomial, what do you get?
2a2.
2a2. Okay.
Mhm.
Okay, so now what we should do is construct the polynomial at the point. Okay, so the polynomial at passing through these 3 points. So the polynomial would be equals to yi minus 1 li minus 1 plus, you can use the Newton method command, okay, to construct method, plus yi li plus y plus 1 li plus 1. Okay, so we'll construct this polynomial now. So the expression will be a little bit large, but doesn't matter. So x minus xi multiply by x minus
xi plus 1.
xi plus 1 and divided by
xi minus 1.
minus 1 minus, sorry, xi minus xi minus 1 xi minus 1 minus xi xi minus 1 minus xi
plus 1.
Okay, plus here x. Okay, so this is the first term. For the second term, I will have yi multiply by x minus xi minus 1
xi minus 1
minus xi plus 1
plus 1
xi minus
xi
xi minus 1 xi minus xi
plus 1.
1. And here yi plus 1 x minus xi minus 1 x minus xi xi plus 1
minus xi minus 1
minus xi minus 1 xi plus 1 minus xi. That. Okay. In order to simplify the calculation, I will consider that we have an equal step between the points. Okay. This is so will have h here and h here. Okay. So an equal step. So x here I will have xi minus 1. Okay. Minus xi. So this is minus h.
Minus h.
And this is minus 2h. So this is 2h square here.
Okay.
And here, this is xi minus xih. And this is here
minus h.
Minus h. So this is
minus h squared.
Minus h square. And here, normally, command is 2h square here. This is 2h. And h, so this is 2h square. Okay, so now I can express my polynomial. So it's 1 over 2h square and by yi minus 1 x minus xi x minus xi plus 1. Okay, plus yi divided by h squared minus, okay, x minus xi minus 1 x minus xi plus 1 divided by okay, ما في divided
لا ما في.
plus yi plus 1 x minus xi minus 1 x minus x. بس هلا what I need هلا is this term a2, okay, from this polynomial. يعني I need all the terms that are in front of the x square, okay. يعني
Okay.
هون رح أعزل, okay, just like I just will calculate the a2 now. I can develop this expression now, but okay, I'm just interested in the x squared.
Coefficient of x squared.
So the a2 here, okay, this term هلا هون راح يطلع لي
1 over 2h squared.
divide here by 2h squared كله, okay.
Okay.
So
yi minus 1.
it's yi minus 1 here, okay. And here I have minus h squared, so
Minus
this is yi, so this is minus
2yi.
and here I have yi
plus 1.
okay. So
Okay.
approximation for the second derivative at the point, okay. If I want an approximation for the second derivative at the point xi, this is equal to
2 times a2.
2 times a2, yes.
Okay.
Okay. So it's the approximation for the second derivative. And this is a formula that is very common. It's very common formula. It's called definite difference formula for the second derivative. You will encounter this very over h squared. Sorry, not h squared. You can encounter this when in the numerical resolution of differential equations and things like that. Okay, so this is a very formula, like the formula for derivative. This would be the formula for the second derivative. Even okay, I could have derived a more accurate approximation for the first derivative using the second order polynomial. So if I want the derivative of the derivative of x at the point xi can be expressed as, okay, is p prime of xi. So because p is equal to a2x squared, okay, so p prime of x is 2 times, okay,
2a2x
2a2x plus
a1,
okay, and this at the point xi, yani. xi plus a1. So you need to calculate the a1, and with this formula you can derive a more accurate formula for the derivative, but using 3 points instead of 2 points. Okay. And you can calculate this formula.
Okay.
So this is basically okay for the session, the problems, and we will start a new chapter, which will be about the least square interpolation, least square approximation next time.
Okay.
في حدا فات هلا but it's too late. Okay. So this is it. If you have any question, you can ask.
No questions. بس تقلك الميل اللي بعت لك اياه تبع الكود طلع بعت لك اياه على تبع الجامعة، الميل تبع الجامعة تبعك مش جيميل.
Okay, I will check.
Okay, so that's it.
Okay.
Okay.
في حدا تاني غيرك عنده questions أو شيء؟
ما بعتقد.
Okay, great.
Okay.
This one I can share the YouTube video. I will see. I will يعني يا بكرة يا I will.
Okay.
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 Yeah. See you
Yeah,
soon.
thank you. Okay. Bye bye.
إذا بدكم فينا
Thank you.
you can يعني reserve this session each week يعني. Okay. So Thursday we can reserve it, and يعني in the meanwhile you receive a YouTube video, so we have one session recorded and one session that is live.
Okay.
We'll do it. All right.
Sure. Okay.
Okay. See you soon, Lakin.
Okay. Thanks. Bye bye.